Welcome to The Explainer. Today, we are tackling one of those technologies that's changing, well, pretty much everything: machine learning. We're going to get right into how computers are making the leap from just following our orders to actually learning for themselves. Okay, let's dive right in, because this right here is the absolute core of it. For decades, programming was all about a person writing a perfect step-by-step recipe for the computer to follow. You had to think of everything. But machine learning, it completely flips that on its head. Instead of giving the computer a set of rules, we just give it a ton of data, all kinds of examples, and we tell it, you figure out the rules. So that big shift from giving rules to letting it learn, that's the heart of the whole thing. But let's really nail down what we mean when we say a machine is actually learning. Right, so here's the deal. Machine learning is a specific field inside of artificial intelligence, and the goal isn't to write a flawless instruction manual. Not at all. The goal is to build a system that can absorb a whole bunch of information, find the patterns hidden deep inside it, and then use those patterns to make smart decisions about new things it's never seen before. It's all about recognizing patterns, not just doing math. That is the million-dollar question, isn't it? And, it's not magic. It's actually a pretty structured process that usually goes down one of two main paths. You can think of it like this. It's the difference between studying for a test with the teacher's answer key versus being dropped in a huge library and told to just explore and find connections on your own. So let's start with that first path, the one that's like being a student in a classroom with a great teacher. We call this supervised learning, and it's called that for a reason. It relies on a teacher who already has all the right answers. In supervised learning, the most important ingredient is something called labeled data. We give the algorithm a massive data set where we've already given it the correct answer for every single example. So we feed it thousands of pictures of cats and dogs, and each one is labeled dog, cat, dog, dog, cat. The model sifts through all of them and starts to pick up on the patterns, things like whisker shapes or ear floppiness. It makes a guess, checks the label to see if it got it right, adjusts its own logic, and then does it again, millions of times, until it gets really, really good at telling them apart. And you see the results of this every single day. Your email spam filter. It learned what spam looks like by analyzing millions of emails that people had already labeled spam. Those online home price estimates, they were trained on all the features and actual sale prices of countless houses. But this brings up a really fun question. What if you don't have any labels? What happens when the machine is left all by itself? And that brings us to the second, more adventurous path: unsupervised learning. This is where we hand the machine a giant pile of raw, unlabeled data and basically just say, go find something interesting. So with unsupervised learning, there's no answer key. The whole point is discovery. The algorithm's job is to dive into the data and find its natural structure, to find groups and relationships that a human being looking at the same data might never even notice. And this is incredibly powerful for businesses. For instance, with clustering, an algorithm can sort customers into different groups for marketing campaigns without being told what to look for. With association, it can power that people who bought this also bought feature you see on shopping websites. And with anomaly detection, it can spot weird credit card transactions that don't fit your normal spending habits, potentially stopping fraud. Okay, so just knowing about these two paths isn't quite enough. Actually building a model that works in the real world, well, it's a bit of an art. It involves this really tricky balancing act. This here is the classic challenge, the bias variance trade-off. If your model is too simple, it has high bias. We call that underfitting. It basically misses the real pattern in the data altogether. But if your model is way too complex, it has high variance and it overfits. It doesn't just learn the pattern. It memorizes every single piece of random noise in the training data. So the moment you show it something new, it completely fails because it can't generalize. The real skill is finding that sweet spot right in the middle. And here's another one of those crucial balancing acts. Let's go back to that spam filter. A type 1 error, a false positive, means a really important email from your boss gets tossed in the spam folder. A type 2 error, a false negative, means a dangerous phishing scam gets delivered right to your inbox. So which one is worse? There's no single right answer, right? It totally depends on what you're trying to protect the user from. Engineers have to make these kinds of judgment calls constantly. And believe it or not, people have been wrestling with these very ideas for a long time. I mean, get this. The very first neural network, way back in 1951, wasn't built with silicon chips. It was put together with vacuum tubes and spare autopilot parts from a bomber plane, all to teach a virtual rat how to solve a maze. The ambition for this has been around for decades. So, we've talked about the what and the how. Let's wrap this up by bringing it all back home to you. Because whether you realize it or not, you are interacting with these systems all the time, every single day. That movie recommendation on Netflix? That's an unsupervised model clustering you with people who have similar taste. Spotify's Discover Weekly playlist? Same thing. Unlocking your phone with your face, getting real-time traffic predictions, translating a web page instantly, seeing product recommendations, even depositing a check by taking a photo. All of these things are powered by the very models we've been talking about. It has quietly become the invisible engine of our digital world. You know, this technology is moving at an absolutely incredible speed, and its abilities are getting more powerful every single year. And that leaves us with a really profound final thought. As we get better and better at designing systems that learn from data, the big question starts to change from how they learn to what values and priorities are we actually putting into that data in the first place? What is it that we really want our machines to learn?